So try substitution first. If you get an answer, great. But if you get 0 over 0 or infinity over infinity, then you've got to try either factoring or fractions or square roots. And again, yesterday we did the substitution and factoring parts. Today we'll do the fraction and square root parts. So you look at these 6 examples, it's like, yep, those are all fractions. You turn the page, and, well, it's not all square roots. There's a couple others in there, but it's mostly square roots that we have to deal with. So let's start with substitution, even though we're pretty sure this isn't going to work. If I substitute negative 5 over negative 5 plus 1, that'd be negative 1 plus 1 is 0. And 5 plus negative 5 is 0. And remember, I'm careful not to say it equals 0 over 0, because it can't equal 0 over 0. It's got to equal something else. So I don't want to say equals, but I do want to get there so that I know I have to try something else. Okay, now for the something else, clearing this fraction. Well, I would like that denominator to go away and make this a simpler fraction to deal with. So what could I multiply by that would clear that denominator? X. Who gets the X? The top or the bottom? Both. Always both. That way, right, if I multiply by X over X, I'm not changing anything. It's still the same fraction. So we distribute the X. On the first term, the X's cancel. On the second term, we get X. And then in the bottom, we get 5x plus x squared. Let's see here. But I could factor the bottom. Take out an x, and that leaves 5 plus x. The factors cancel. Maybe I should have said this earlier. Remember when we get 0 over 0? Do you remember what that means? What's happening on the graph? A hole. But a hole also means that we should have factors that cancel. So sure enough, we got factors that cancel. And we knew the hole would be at negative 5, because that's what made the 0 over 0. And sure enough, we have a factor that would lead to a hole at negative 5. So trying to connect the pre-cal knowledge with the calculus knowledge and how it's kind of all the same thing. So limit as x approaches negative 5 of 1 over x, well, that would be negative 1/5. Again, after you do your algebra magic, you substitute again, and hopefully it works once you fix the hole. Part B, or example B. Substitution first. Really easy to see this one. If I plug in 2, I get 1/2 minus 1/2, and 2 minus 2. So I know there's a hole at x equals 2. Let's go see if we can sort of prove that or show that. What would I need to multiply by on this one to clear out all the fractions? So an x would fix that x, but what would fix the 2? Right, so I multiply by x to fix the x, but that's not enough because I also need to cancel the 2. So also 2. So 2 and x. So let's distribute the 2x. To the first term, the x cancels and we're left with 2. To the second term, the 2 cancels and we're left with x. And then in the bottom, you know what? It's probably best, after we did that last one, to not distribute it, to just leave it as 2x times x minus 2. Because we're hoping we're going to find factors that cancel. That's what we're looking for. 2 minus x over x minus 2. Can those cancel? Uh-oh, I saw some yes and some no's. And the answer is sort of in between. The answer is kind of. So how do they cancel if you want to cancel them? Because they're not equal to each other. So I can't just mark them both out and move on. Yeah, so I can either, there's a negative in there somewhere, and there's 3 different ways to handle it, but the easiest way is, these are off by a sign, right? 2 minus 3 and 3 minus 2 are off by a sign. 2 minus 4 and 4 minus 2, off by a sign. So you can cancel them as long as you replace it with a negative 1. So you were sort of both right. If you said yes, you can cancel them, kind of. If you said no, you can cancel them, also kind of true, because you can kind of cancel them. Canceled means there was a hole there, sure enough. That's what we said already. Now let's try our substitution. So negative 1 over 2 times 2, negative 1/4. How about C? What should we multiply by on this one to make all of the fractions go away? X plus 2 and x plus 1. Top and bottom, so that we don't change the fraction. We'll change the look of the fraction, but not the value of the fraction. So on the first term, the x plus 2's cancel, and we're left with 5 times x plus 1. On the second term, the x plus 1's cancel, and we're left with 4 times x plus 2. And then in the bottom, I probably don't want to multiply all those out, because the whole reason we're doing this is hoping something cancels. So let's just leave them all and hope that somebody cancels. Oh, I kind of skipped a step on this. I didn't substitute. I didn't substitute because I know I'm on this part of the packet, so I know it's going to get 0 over 0. Even without substituting, I'm pretty sure there's going to be a hole at x equals 3. So I'm hoping somehow x minus 3 shows up in the top so I can reduce that. Let's see what happens. 5x plus 5 minus 4x minus 8 when I distribute the negative 4. So sure enough, that becomes x minus 3 in the top. The x minus 3's will cancel, reminding us again that yes, there's a hole at x equals 3. But just because there's a hole, we can still have a limit there. So we've done our algebra trick. Now let's substitute. Oops, plug it in for x. So 1 over 5 times 4. 3 plus 2 is 5. 3 plus 1 is 4. 1/20th. This is the kind of stuff that earns this stamp all year long next year. Like, you know the calculus part of it, but can you fight through all of the algebra stuff to get to your answer? And I guess we'll find out next Wednesday. Let's skip D because it's kind of the same thing. You'd multiply top and bottom by x plus 1 and x plus 2 and hope that an x minus 1 shows up to cancel. Example E. What do you want to multiply that would cancel? Well, I guess we should substitute first. Let's see. Substituting 5 would be 10 over 10 is 1. 5 over 5 is 1. And then 5 minus 5. So yes, 0 over 0. So there's a hole at x equals 5. So I'm expecting that x minus 5 to cancel eventually. And we just got to do our algebra magic to get there. So what should I multiply by that would cancel a 2x and an x?
X plus 1 times 6 plus 2.
I think you're looking at the previous one. We skipped D. It's the same. D is the same as E, so we can skip that one, or C. But on E, what do I multiply by that would cancel all my denominators? Good, 2x. I don't need to do 2x and x. That's a common mistake on that one. Just 2x will work. So on the first term, the 2x's cancel. On the second term, the x's cancel. And that leaves 10 minus 10. And in the bottom, we said we were going to leave it alone. What, did I do something wrong here? Because I'm still getting 0 over 0. Let's graph it and see what it looks like, because then we can for sure know what's going on here. Oof. Mode, function. I don't have one of the nice calculators with the fraction bars up here. 10 over 2x minus 5 over x divided by x minus 5. And I really want to know what's happening at x equals 5. So I don't want to go negative 10 to 900. I'm guessing this was from the projectile stuff. So I don't need to go to 100 either. Let's try that. Zoom out a little bit. Alright, looks like there's an asymptote at x equals 5, which sort of explains, maybe explains, I can't fix this. I tried my best to fix it, and I still can't fix it. I've got 0 over 0. Boy, how do I explain this? Let's see. This is a tricky one. The top is definitely 0. 10 minus 10 is 0. The bottom, when we plug in 5 down there, that's not exactly 0 because we're getting close to 0. Right? Because we're getting close to 5. So the top is like a hard 0. It's definitely 0. 10 minus 10 is 0. Not close to 0. 0. The bottom is a little bit trickier because when we plug in 5, we're getting close to 0. So if you're getting close to 0 in the bottom, that should be an asymptote. But a hard 0 on the top would make it 0. This is a weird one. Yep, but that's right. I don't think you're going to get one like this on the short answer is we tried to fix it and we still got 0 over 0, so this one didn't work. It doesn't exist. It still doesn't exist, even though we tried our trick to fix it and it wasn't fixable. That is a weird one. Let's do the last one. This is kind of a weird one too here. So substitute 2, we get 0 in the top. That's easy. In the bottom, I get 4 over 4 minus 7 over 9 minus 2 is 7. Yeah, that's 0 over 0. So let's go about fixing this guy. Hope it's not as bad as that last one. Let's multiply by x plus 2 and 9 minus x, top and bottom. Clear out all our fractions. This time we're clearing fractions in the bottom rather than the top, but same thing. So this time I'm going to leave the top factored because I'm hoping something will cancel. In the bottom, let's see, the x plus 2 cancels on the first one. And on the second one, the 9 minus x cancels. Algebra. So I'm going to leave the top alone and just work with the bottom. 36 minus 4x minus 7x minus 14. So that would be negative 11x negative 11x. 36 minus 14 would be 22. Does any of that cancel?
Negative 11, take that out.
Yeah, take the negative 11 out, and then something might cancel. Take a negative 11 out, that means x minus 2. So the x minus 2's will cancel. All that work, what's left to do now?
Substitute.
We still got to go back and substitute. Limit as x approaches 2. So 2 plus 2 is 4. 9 minus 2 is 7 over negative 11. So 28 over negative 11. A lot of algebra stuff. I don't like to chase people off of calculus. I want you to try it. But if you can't even follow what I'm doing, much less do it on your own, then you might need to revisit the course selection for next year. Like, this is what we do in calculus. There's calculus going on, but you have to have a strong algebra background to be able to do all of that. So if you can follow along and handle it, fine, you'll be okay in calculus. But if you're struggling to figure out, wait, what do we multiply by? How do I distribute? What cancels? How do I factor out? Like, if that's a struggle, then that's a college algebra thing that you need to work on. And so maybe college algebra is a better choice. Again, I don't like chasing people off of calculus, but it might be a better pick if this seems overwhelming, because this is the algebra basis for moving forward in calculus. All right, so that was method 3, handling fractions. Method 4 is handling square roots, which we've done before. So this one isn't too bad. You've handled conjugates before. So as always, start with substitution. If it doesn't work, then try something else. So if I plug in 16, square root of 16 is 4. 4 minus 4 over 16 minus 16, yep, that's 0. So what do you think, it says conjugate, what do you think we should multiply by on this problem? Oh, careful. So usually, someone said x plus 16. I'm not going to call you out on the video. But yeah, usually we conjugate the bottom to fix it. But the problem with this is the square root, not the denominator, but the square root. So when I multiply by a conjugate, I want to multiply by a conjugate that involves the square root. So having said that, what do you think we should multiply by?
Square root of x plus 4.
Yeah, square root of x plus 4. Now, it might be new that we're multiplying by the conjugate of a top, of a numerator. let's do the conjugate thing first. So square root of x times square root of x is x. The outside and inside cancel out. That's why we multiply by a conjugate. And then negative 4 times positive 4 is minus 16. What do you think about the bottom? Should we FOIL the bottom? Why not? Because x minus 16 is sitting right there, like begging you to cancel him. So let's try 16 again. Substitution. So 1 over square root of 16 is 4. 4 plus 4 is 8. 1/8. Example B. If I plug in 5, I want to multiply by the conjugate right here, so I'm going to do the plug in sort of out of the way here. 5 minus 5 is 0. 5 minus 1 is 4. Root 4 minus 2 is 0. So yes, this one's another problem child here. All right, how about the conjugate of this guy? The square root thing's in the bottom, but which sign do I change is the question. Good, the negative in front of the 2. So I'm going to multiply by square root of x minus 1 plus 2.
Why do you, okay.
Because that should make the square root stuff go away. So let's leave the top alone. We multiply by a conjugate to fix the conjugate stuff, to fix the square root stuff. So let's fix that first and see if something happens that we don't have to actually multiply the top, like the same thing happened in number 1. So fix the conjugate part first and see what happens.
Why is the x plus 1 and x minus, why are they different?
Oh, good catch. That should be x minus 1. Yeah, otherwise we're not multiplying the top and bottom by the same thing. All right, so we're leaving the top alone, hoping that something magical happens and we don't have to worry about it. But we're multiplying by conjugate, so probably something magical is going to happen. Square root x minus 1 times square root x minus 1 is x minus 1. The O and the I would normally look terrible for this, for foiling purposes, but the O and the I of FOIL always cancel out with conjugates. Plus 2 root x minus 1 minus 2 root x minus 1 goes away. And then negative 2 times 2 is minus 4. Oh, we've seen this before. Can I cancel 5 minus x and x minus 5? Right, sort of. If I know that they cancel to negative 1. Okay, substitution again, but hopefully it works this time. So negative 1 times square root of 4 plus 2. 2 plus 2 is 4, so negative 4. Conjugates. All right, C. That looks weird. I don't even see a square root. Let's plug in and see what happens. Cosine of 0 is 1. Sine of 0 is 0. So yes, I get 0 over 0, so I got to do something. There's no square roots there, but the section we're in is conjugates. There's really only one candidate there. What do you think we should multiply by? What do you think would be a conjugate? A I don't follow. It's not a square root. Oh, we don't even have to worry about that. It's easier than cosecant and secant stuff. Conjugate. What do we do when we say conjugate? What's the big deal when we multiply by a conjugate? Change the sign. Change the sign from a minus to a plus. So let's multiply by cosine of x plus 1. Which may seem a little weird, like how in the world is that going to help anything? But it's the magic of conjugates, so let's see what happens. Okay, so we multiply out the conjugate side, we leave the other side alone and hope something happens. So in the top, cosine squared x minus 1, and in the bottom, sine of x times cosine of x plus 1. Anything?
The top equals sine x squared.
The top equals something, right? Because sine squared plus cosine squared is 1. So cosine squared minus 1 would be negative sine squared. Yes, no? From our previous, again, that's the one we use most often. Of all of those trig identities, that's the one we use most often. So cosine squared minus 1 would be negative sine squared. How does that help us? Cancel. What can we cancel? Yep, we can cancel one of the signs. So negative sine x over cosine x plus 1. All right, let's try again with substitution. Sine of 0 is 0, but that's okay. It's okay to have a 0 in the top. It's just if we get 0 over 0, then something's wrong. Cosine of 0 is 1. 1 plus 1 is 2. What's 0 over 2 equal to? 0. So sines and cosines also follow that conjugate thing. So I think we can pass on D because it's the same thing. E is, or F is the same thing. I think we can pass on E if you can tell me what we should multiply by. There's multiple square roots in there.
The square root of x plus 2 plus the square root of 2.
Perfect. So it's going to look ugly, but it's going to work out. So why don't you finish E and then we'll be done. You finish E. Test your algebra skills. So multiply out the conjugate side of the fraction. Leave the non-conjugate side of the fraction because the hope is something cancels. And sure enough, it does. And then we're not through until we substitute one more time. So 1 over square root of 2 plus square root of 2. Oh, I'm glad I picked this one. Speaking of calculus is easy, algebra is hard. What's the square root of 2 plus the square root of 2?
2 square root of 2.
Good.
No.
Oh, you almost backed away from your correct answer. It's you can't like add the insides and tell me it's square root of 4. It's, you treat them like variables, right? It's that one variable plus the other variable. There's 2 of them, so there's 2 square roots of 2. And you know what? Since we're doing calculus now, we're okay with that answer, which might seem weird, but in calculus we're okay with square roots in the bottom. So we're okay with that. If you fix it, that's fine too. Square root of 2 over 4, also okay, but yeah, I'm just going to make the call. Since we're in calculus now, or since we're doing calculus now, we're okay with square roots in the bottom, so we don't have to fix square roots in the bottom anymore. That's your reward for making it to calculus. It's the little things, right? You can leave square roots in the bottom. Alright, you can guess what you're going to do on F. Probably multiply top and bottom by 1 plus sign and see what happens. Here's your summary. We've said this a whole bunch of times. Keep these techniques in mind. I'm just going to kind of reorder this. First, substitution. Then, if you get 0 over 0, or infinity over infinity, then you try one of the others. So you always start with substitution, then you try the others, and then, I guess once you try the others, you actually go back to substitution and hope that you fix the problem. Alright, your assignment is worksheet 2, still on worksheet 2, but now the back side of it's 10 through 18. Worksheet 2, 10 through 18. And you look, and there's 5 fractions and 4. Yes, 5 plus 4 is 9. 5 fractions and 4 conjugates on that back side of worksheet 2. Again, lots of algebra, but that's the name of the game in calculus a lot of times. Is like the calculus isn't bad, it's the algebra that gets people.